Hello everyone, I am Dr. Godandaraman. In this section we are going to discuss with Stokes theorem problem. See the problem. Verify Stokes theorem for a vector field. Define f vector equal to x square minus y square into I vector plus 2xy j vector in the rectangular region in the xy plane bounded by the line x0, xa, y0, yb. Now the Stokes theorem is nothing but Stokes theorem, line integral equal to surface integral, integral over C f vector dot dr vector equal to double integral surface del cross f vector is a curl f vector dot n cap ds, n cap ds. So this is a Stokes theorem. Now verify Stokes theorem is nothing but to find the left hand side, right hand side, the two values are equal, then the Stokes theorem verified. Now I am taking first right hand side. So whatever, choose right hand side or left hand side, but now I am choosing first right hand side. Now the right hand side is nothing but the values are right hand side double integral surface del cross f vector dot n cap ds. Now the given line, what is the given? x0, xa, y0, yb. Now to consider, this is the x axis, y axis and the point 0. Now see, this is the x0. x0 is nothing but the line to consider. These points are A, these points are B. Now when x0, the whole line x0, then xa, what is the next line? xa. xa means this whole line x equal to a. Then y equal to 0, this whole line y equal to 0, then y equal to b, this whole line, because I consider b, this whole line y equal to b. So this is our region, this is our area region. So now consider this area, this is a y equal to b. So this is a area. Now the rectangular lines, the point is 0, o, a, b, whatever. So 0, o, a, b, c. This is a rectangular point, o, a, b, c. Now first of all here to find the del cross f vector, del cross f vector, the given f vector is nothing but, what is f vector? F vector equal to x square minus y square into I vector plus 2xy into j vector. Now to find del cross f vector is nothing but curl f vector, I vector, j vector, k vector. Now the first one is del. Del means, del is nothing but I into dou by dou x. What is a del? I into dou by dou x, j into dou by dou y, k into dou by dou z. What is a del? I into dou by dou x, j into dou by dou y, k into dou by dou z. Now I vector coefficient, I am writing here I vector coefficient dou by dou x, j vector dou by dou y, k vector dou by dou z. And the next f vector. F vector is here, the f vector I coefficient value, j coefficient value, substitute x square minus y square, 2xy, then 0. This is a determinant. For here, plus minus plus minus plus minus plus minus plus. So the first row to consider is nothing but the first row here. This is the first row here. The first row I, j, k. So plus minus plus. So this is a way we can mention here plus minus plus. Now first of all, the first term I vector. When I am choosing this I vector to leave the row and column, suppose I am choosing this I to leave row and column, this minor matrix to take the determinant dou by dou I of 0 minus dou by dou Z of 2xy. Therefore, the value is nothing but I vector into dou by dou y of 0 minus dou by dou Z of 2xy. This is the I vector. Minus j vector, again to consider this column and row, j vector. Why I mention here minus? Because of this part is minus, second term minus, therefore minus j vector to leave this column and row, dou by dou x of 0 minus dou by dou Z of x square minus y square, plus k vector, again to leave this column and row, this cross multiplication is nothing but k vector dou by dou x of 2xy minus dou by dou y of x square minus y square. For this term, see first term, the constant d by dx of the constant 0, when differentiate constant 0. Therefore, here dou by dou y, this is the constant, and dou by dou z, the whole term constant. So, when I differentiate constant 0 minus 0 minus j vector, for this term constant, the whole term constant because z only the variable, therefore 0 minus 0 plus k vector, differentiate partially with respect to x, here variable x, here x, y, y. Now the derivative y, x, y. Therefore, the first term 2 x differentiation 1 y minus the first term, because of its addition subtraction, whenever we are differentiating, when the constant is addition subtraction, the value 0. Now x square with the subtraction, therefore the constant 0 minus y square differentiation 2y. Now the first term 0, second term 0 plus k vector 2y, minus of minus plus 2y, this is a 4y k vector. The 4y k vector is nothing but del cross f vector, del cross f vector, curl f, del cross f is curl f. Now find the right hand side. What is the right hand side value? Right hand side, double integration of surface del cross f vector dot n cap ds. Therefore, double integration del cross f vector value 4y k vector dot n cap is k vector, because of this is a unit outward normal vector, because only one vector, k vector is nothing but only one vector, therefore only one side direction. For see here the k only one direction. If three direction means we can use the unit normal to find, then to substitute, but here only one direction, therefore n cap is k vector. What is a k vector? Double integration 4y k vector dot k vector into ds. So what is the k vector into k vector? Dot product value 1. Now what is the value? Double integration 4y ds. The surface is nothing but ds, to write the form of dx dy, double integration 4y dy dx or dx dy. Suppose if I consider y is the function, then to consider dy by dx. X is the function, then to consider dx dy. So whatever we can choose. Now I am choosing here y is a function, dy dx. Therefore the y range is given line value 0 to b, x range given 0 to a. Now first integration with respect to y. So when I integrate x0 to a, 4 constant, y integration y square by 2. Then lower limit, upper limit. When I substitute lower limit, upper limit, and this value will be cancelled to 2 times. Integral over 0 to a, 2 times of b square minus 0 square. Upper limit minus lower limit. Substitute b where y. Therefore, x0 to a, 2b square into dx. For here 2b square constant. Therefore, x0 to a, 2b square, when I am taking out to integration of dx, 2b square dx integration x 0 to a. So substitute upper limit minus of the lower limit, a minus 0. Therefore 2ab square, this is a right hand side value. Now to find the left hand side, if the same value 2ab square, then the given f vectors verified Stokes theorem. Now the left hand side, to consider left hand side, integral over c f dot dr, f vector dot dr vector. Now the picture, see. So this is a rectangular region. So now to calculation f vector into, so integral over c f vector in dot dr vector, f vector dot dr vector. For here, see line, look at here line, this is a one line, this is a one line, this is a one line, this is x0, xa, y0, yb. But the region to calculate the addition of 4 lines, so only the region it's a possible to calculate. O, A, B, C or A, B, C, D, whatever rectangular region. Now O to A, so this is a consider for this line is nothing but O, A, B. So f integral over O, A, B, C, f vector x square minus y square I vector 2xy into j vector dot d into r vector is xi vector, yj vector, zk vector. So dx I vector, dy j vector. I dot I value, which one? I dot I, j dot j, one other value 0. Therefore integral O A B C x square minus y square into dx plus 2xy into dy. The whole line O A to B C to find individual. What is the individual? See integral over O to A plus A to B plus B to C plus C to O into x square minus y square dx plus 2xy into dy. So the single line to split with 4 lines. So only the regions possible to calculate. So this region separate to calculate or individual. So unique. Okay. So now I am going to take this lines. First of all, see, first this line consider O to A, okay, into x square minus y square dx plus 2xy dy. So this is the first one, plus second line A to B x square minus y square dx plus 2xy dy. This is the second line, plus third line B to C x square minus y square dx 2xy dy plus co x square minus y square dx plus 2xy dy. See, this picture is nothing but, now to consider, this is a picture. See the line. First of all, what is a line? Now see first line. What is the first line? Integral O to A. Integral O to A. If integral O to A, y value 0. What is the value 0? Y value 0. When y 0, then derivative y differentiation dy 0. dy 0. Now see this line, okay, this line y equal to 0, dy equal to 0. Now this line equation is nothing but x square minus y square dx plus 2xy dy, then plus. So what is the next? Integral second a to b, where from a to b. So the a to b is nothing but x equal to a to b, from this line to this a to b, x equal to a. Therefore x equal to a, x square minus y square dx plus 2xy dy. Now this is the differentiation dx 0, dx 0. Now what is the third one? Integral over x square minus y square dx plus 2xy dy and plus integral x square y square dx plus 2xy dy. So third line. So where is the third line? B to C, third line. This B to C, y equal to b. So when y equal to b, then dy, when derivative, the b constant 0. And then for this term, the final b2, c2o x0. So c2o x0, x0 dx 0. Therefore to substitute this value, integral, the first line to substitute, where to substitute? X y. So dy 0, dy 0 means here 0, dy 0 means the whole term 0, because dy 0 whole term 0, y 0 means this term 0. Now what is the term? Integral x square dx, because other value 0. Now this is the range, x range. So the a to first limits O to a, x limit, x limits means from x line is nothing but where possible. See, this is a possible x0 to a possible, x0 to a. The points is nothing but x point 0 0. So this is a 0 comma 0, this is a comma 0, this is a comma b, and this is a 0 comma b. So this point from O to a, x range. What is the x range? x0 x a. Therefore this value x nothing but 0 to a. Plus next x is a dx 0. When I substitute x a dx 0, dx here 0 means this term 0, the whole term 0. Now x a means this place is a. Now integral the first term 0 to a y dy. Now the y range, from y range, where I am taking y range from a to b y range. A to b y range means, see, this is a A to B. Where the A to B, see, this is a A to B y range 0 to B. 0 to, see, 0 to B. Therefore, the y range 0 to B. Then plus integral, next substitution is nothing but the substitution, see, dy 0. So, dy 0 means the whole term 0. yb, then this place is substitute y equal to b. Now, integral x square minus b square into dx. Now, what is the x range? Why I am writing x range? Because of this is the variable. This variable range only we are using here. So, dx means x range. Where the x range? First O to A to B, now B to C. So, B to C to consider, this is a B and C. So, A to 0 for x region, A to 0. So, x region A to 0 plus next for here, what is the value? Dx 0. So, x 0 means whole term 0. X 0, this x 0 means whole term 0. Therefore, this is a value 0. This is a value 0. So, dx 0, x 0. Now, the first integration. So, what is the integration? See, x square integration x cube by 3 0 to a plus 2a constant, y integration y square by 2 0 to b plus here integration x square integration x cube by 3 minus b square x a to 0. Substitute upper limit minus lower limit. When I substitute upper limit minus lower limit, then a cube minus 0 cube by 3. Upper limit minus lower limit plus this 2 cancel. Now, a upper limit b square minus 0 square plus upper limit 0 minus 0 minus lower limit a cube by 3 minus a b square. Now, a cube by 3 plus a b square minus a cube by 3 for this term plus a b square. To cancel this 2 term, now the value is nothing but 2ab square left hand side. Now, see, the left hand side and the right hand side value, left hand side equal to right hand side. When the value of left hand side, right hand sides are equal, then the F vector verified the Stokes theorem, hence proved. Thank you.